with the word momentum. And momentum is going to be how difficult it is to stop an object. That means it has to be moving. If it's moving, then it has momentum. Well, wait a minute. How about, for an example, let's go down to very, very tiny. What about an atom or an electron? Let's go even smaller. Do they have momentum? If they're moving, yes, they are. And what we know scientific-wise is that every atom has some type of movement, some type of vibration, or it wouldn't exist, right? Those electrons are continuously vibrating and moving. So, yeah, even so, as small as an atom, as small as an electron has momentum. But again, don't forget, the heavier the mass, or the faster that it's moving, the more momentum it has. Now, the opposite of this momentum or this movement is going to be impulse. Impulse is trying to slow down the movement. Now, the way to slow down an object, kind of like if you're driving, if you want to slow down your car, you have to apply the brakes. Those brakes are going to apply a force to your tires for a certain amount of time to get you to come to a stop. Now, is it going to be a instantaneous stop, or is it going to be a slow, easy stop? Okay? Now, that is going to determine how much force is experienced by the car or by you, right? You probably go home, for those of us who are driving, and if you're like one of those aggressive drivers and slams and hits on the brake very often, somebody at home is probably like, whoa, slow down. You're going to end up having to get new brakes, and that's going to cost, $182 or something. Like, slow down. Take it easy on the brakes. So why do we take it easy on our car brakes? Number one, yeah, we don't have to replace them so often, right? It costs quite a bit of money. But number two, when you are going to stop quickly and suddenly, you're increasing all of that force onto your brakes. You're going to ruin those brakes a lot faster because of all that force. Same thing for our bodies, right? We saw, we didn't see it, but we have a quick little video today for an example when it comes to football. We've been using that example, okay? When football players are out there, they have newer and newer and newer helmets. I mean, if you want to compare the helmets from 1922 to 2022, there's a big difference in their football helmets, right? Why? Because we want to decrease the force experienced by a person's brain when it comes to that impact, right? How do we do that? By increasing the amount of time, which will now decrease the force. And this J, or impulse, is the opposite of momentum. Momentum is moving, impulse is slowing it down. If impulse is equal to or greater than the momentum, it's going to stop it. If impulse is less than the momentum, it can just slow it down and won't stop it. Okay? So just kind of going back as a little review. Then we came over here and we said the cool thing about this is that impulse and momentum have the same SI units, which is awesome. And because we can have those units equal to each other or the same, we can set up our equation equal to each other. If we have three variables, we can solve for the unknown number 4. Alrighty? Or we can manipulate it and we can say J equals MV. Or we can say FT equals P. We can rearrange it how we see fit because they equal each other. Again, momentum is movement, impulse is slowing it down. The opposite, because they're the opposite, we set them up equal to each other. Then we started talking about how, whoa, let's try to slow down or decrease the amount of force on an object. Specifically, it comes to people. Too many people in the past, they are noticing that there's concussions and injuries that are going on with football and baseball and hockey and, whoa, wait a minute, cars, right? We get in cars. We depend on cars to travel so much. So how do we decrease the amount of injury? Now, again, though, this is not going to just permanently just kind of like bubble wrap you and you're going to be okay. Because if your car is moving, we said, because momentum is very closely related to Newton's first law of motion. If your car is traveling at a velocity of 75 miles an hour, you're traveling at 75 miles an hour. Wait a minute. Your heart, your lungs, your intestines, your organs, your spleen is all moving great. This car just got into a bad wreck, unfortunately. We started building cars to where, yes, true story, they do crumple up and they get some major damage. But that major damage is increasing the amount of time for you to come to a stop. We call those crumple zones. We have seat belts to help slow our bodies down so we don't go through the windshield. And we started to put in airbags, and some cars not only have front, but also have side airbags to help kind of like protect us. So we can slow down while we're in that car when we get into a wreck. Well, you're kind of bobbling back and forth in that car wreck. That you haven't came to a complete stop. And so while we increase that time, we're going to decrease the amount of force. Unfortunately, it doesn't always work. A lot of times, if this is a severe car wreck or severe wreck, people will go to the hospital, and sometimes you're like, if you've ever been in a bad car wreck or seen one, a lot of times police officers are like, hey, I think maybe you should just go ahead and go to the hospital just in case. And you're like, oh, I feel okay. You might feel okay, but do you know whether or not you have internal damage? Do you have a slight fracture or a slight break inside of you somewhere? And so because of that, you have a seatbelt on and an airbag, but your organs don't have that. They're still traveling at the same velocity your car was traveling, okay? So there is a good chance that you can have maybe some internal damage from a horrible bad car accident, all righty? Then we ended up here at this part. There's where we ended up. A couple of other examples. We've already talked about helmets and how they have this padding. We also talked about padding, hopefully between Tuesday and today. When you went inside your vehicle, you touch the dashboard and you're able to push down on the dashboard. You can feel that it's kind of spongy. And then it says follow through. So I'm going to pause real quick.